Oh, there's my dog. Good morning. Hello, wherever you are. There's people outside. Sorry about that. We're going to push through anyway. Welcome back. We've got a video. Why did the orange stop in the middle of the road? It's because he ran out of juice. All right, here we go. We're continuing on with probability distribution. And we're going to look at basically another way to find expected value and variance. And it's going to be by integration. Look at the way I did that integration. Very clever, very smart. Well done, me. So what we're going to do is we're going to realize now that we no longer need to do that whole table of values method, or we don't have to times and plus everything together and put everything together. If we have a PDF, right? If we have the probability distribution function given to us, we can simply integrate. That gives us the, I guess, the cumulative distribution area, and then we can use, we can integrate to actually find our expected value. Okay. Now the way it works is these are your two formulas here. I suggest that these ones here are written down. Now, from memory, these ones are not given. Actually, you know what? Maybe they might be. Let me double check that for you. Check right now. So it is not given to you. So these ones you will have to remember. They'll give you the expected value for normal and the variance for normal as well. But if you were to use integration or find it in different means, these ones are not given to you. So I would write these down, memorize them. The main thing here is for e to the x, it's x times fx. So it's just whatever your function is, just times that by another x, and I'll show you what that looks like. For your variance, it's going to be very similar. And your variance, you kind of always need your expected value regardless. So I'm going to have to find the mean or the mean here. And so I'm going to have to find it from this question here. So once you find the mean, your variance becomes easy. I suggest the second one is probably a bit easier because using the top one means you have to expand things out, and it's just not a fun time. I would suggest using this second one down here because it's a little bit easier. All right, let's move on. Okay, now let's just remember standard deviation as well. That's the last little thing. It's your square root of your variance of x. All right. Now let's go. Let's let your PDF in this case be, I hope that's not too loud. Let's let your PDF here be like, let's say, for example, it's 1 on 8, right? Between x is 0 and 8. So to find the mean, remember the mean, I'm going to write this in blue. The mean is given by this. It's between b and a of x of fx, right? dx. That's it. So in this case here, if it's x times fx, it's going to be x times 1 on 8. And we're going to integrate that between our two values, and we've got dx. So in other words, we're just integrating x on 8 dx between b and a. Hopefully that's making sense. Okay, so to integrate, raise it to the power x squared on 16. Right, and we're going to integrate that between our two values here. And I probably should have written it in this question before. It's between 0 and 8. Oh, buddy, it's okay. Okay, so here it'll be 64 on 16, take away 0 on 16. And that actually should just become, is it 3? No, is it 4? I think it's 4. It would be 8 on, wait, 8 on 2. Yeah, it's just 4. So it'll be 4 units. And so that's your mean. In this case, 4 will do. Okay. So far, so good. Now for variance, remember that variance is given by this formula here. It's between b and a, and it's going to be x squared fx dx. And then you just take away the mean squared, which is, I guess, that number up there. All right, so that means it'll be between 0 and 8 again. And it's going to be x squared times fx, which is 1 on 8. going to be dx. And then take away mean squared. So in this case, it's going to be take away 4 squared. So if I calculate that, that becomes x3 on 24, because I raise it to the power and then I divide by the new power. So 8 times 3 is 24. So I'm dividing by that 24. And I'm going in between 0 and 8. And then once I've done all of that, then I take away 16. So hopefully I don't have a calculator on hand. Where's my calculator? Oh, it's right here. What a noisy. So it's going to be 8 to the 3. So it's going to be 512 divided by 24. It's going to be 64 on 3. Take away 0 on 3. And then all of that take away 16, which is mean squared. So 64 on 3, take away 16. That's just going to become 16 on 3. And that's going to be your variance. To find the standard deviation, guess what? Just going to be the square root of your variance of x. And we found out that that's going to be 16 on 3. So taking the square root of that is going to give us 4 over root 3. And I guess we don't really want it to be irrational denominator. So we want to rationalize it. So it's just going to become 4 root 3 on 3. Okay. And that's your standard deviation there. Okay. Hopefully that makes sense. Keep it short and sweet. Sorry about that, and enjoy. I'll catch you guys later. Bye.